Okay, hi everyone. I'm going to show you how to solve this problem. So the problem says if a football is kicked straight up with an initial velocity of 128 feet per second from a height of 5 feet, which would be the kicker's leg, I guess, how high up the leg is, then its height above the earth is a function of time given by h of t equals negative 10t squared plus 120t plus 5. Time, in this case, t is your time in seconds, and h of t would be the y, like the y-intercept, and that is the height of the ball. So if you look there, I created a graph, and you'll see that it's a parabola. Okay, and it's a parabola that starts at 5, because remember the y-intercept on this example is 5, because that's where the height of the ball starts. And then it kicks up in the air. So it kicks up in the air and then reaches a vertex up here and then comes down in a parabola motion. So what we have to determine is the maximum height, which is the vertex. So let's start by solving this. So let's look at the function. We're going to have to complete the square to solve this. You can do it another way, but completing the square in this case is going to be the easiest way. So we start with h of t equaling to negative 16t squared plus 128t plus 5. Okay, so remember for these type of problems what we're going to do is first factor out what we can and then move to the 5 to outside the factoring parentheses. So we're going to factor out a negative 16, so that leaves us t squared on the inside and a minus 8t. And then some spaces and then a plus 5. We have to leave space in here for what's going to be our number to complete the square. Now you notice that negative 16 times negative 8, negative 16 times negative 8 is the 128. So we've got that part right. So we're getting close on this part, but remember we got to figure out what it is that we're going to put right here. What are we going to put right here in this spot? Alright, so remember how you find that is you take the negative 8, so you take this negative 8 and you divide it by 2 and then square it. So if I take negative 8 and divide by 2, I get negative 4. And then I square that value and I get 16. So what I'm going to do is I'm going to put here a plus 16 here. Now here's where it gets a little confusing. We added plus 16 here. Normally we would just subtract 16 over here, but that's not the case in this one. The problem is that we have the negative 16 here times the plus 16. Okay, so we're actually taking negative 16 times 16, which is negative 256. So the net effect of the negative 16 and the plus 16 is a negative 256. So what we have to do is add 256 to the end of this equation to make it work. So let's see what the next step is for completing the square. Now we actually can write the completed square, and it becomes t, and remember it's half of negative 8, so it's negative 4 squared, and then it's plus 3, what is that, 261? 261. Okay, we're done. We now have the equation for this function, and we have it in the proper format. So what's our vertex? Well, now looking at this, now that we've completed the square, the vertex for this function would be 4, 261. And so what that means in terms of t and h is that at 4 seconds in, 4 seconds in, 4 seconds in flight, it will reach its maximum height of 261, in this case, feet. Okay? So that's it. Now what's interesting is you think about punters, the hang time for punters. Take a look at the NFL and see what the hang time for punters is. Hang time for punters is not normally 8 seconds, I don't think. So this is pretty, this graphic is pretty, might be a little bit off in reality. But let's do one more step, and that is, what time does the ball hit the ground? So what we're looking for now is what happens here. When does it hit the ground? When is y equal to 0? And so that's what we got to do is we got to find the x-intercepts here. the two x-intercepts, by plugging it into this equation, by going into this equation and solving for it. So let's start again with what we had and see if we can solve for it. So in this case now, instead of this, what we want is we want this to equal 0. We're saying, when is this 0? What time is this going to be 0? Is my y value, or h of t, going to be equal to 0? So I have to solve this equation right here. So, well, I have my completed square equation, which might be easier to use. Once I teach you about quadratic formula, we can use that. But let's go back and we'll use that. We're going to set this to 0. Oops. Let's just start with this function. And we'll set this to 0. Alright, so our first step is we're going to subtract 261 from both sides. So when we subtract 261 from both sides, we get 261 equals the negative 16t squared. Okay, our next step is we're going to divide both sides by 16. Okay, so when I divide both sides by 16, on this side I get 16.3125, and on this side I get nothing. Okay, next step, we're going to take the square root of both sides. So we take the square root of this. Take the square root of this. Now remember, when you take the square root of an x squared, a t squared in this case, we're going to have a plus or minus value to deal with. And I don't know where, there it is. Plus or minus. Okay, so what we get out of this is, on the left, we get 4.039 rounded. And on the left, we get t minus 4. So I'm going to add, but remember this is plus or minus. So in the two cases, what happens is I would either have t equals 4 plus 4.039, or t equals 4 minus 4.039. Okay, so our answers, and these are approximates because of the 4.039, these are approximate answers. .039 or minus 0.039. Now, why does it negative 0.039? Well, the problem is that in this problem, remember, we started at a height of 5 feet for the time. So we just are really extrapolating back to when it was 0. So this answer right here you really don't need. This is the answer you want, 8.039. So what this means is that when it hits the ground here, it's going to be at 8.039 seconds. I do not know why this is giving me attitude. There we go. Okay, so it's going to hit the ground at 8.039 seconds. So you can put that here. Ground hit at 8.039 seconds, approximately. Okay, I hope that's helped you to understand this function and this problem. Thank you.